Good evening. I am again kind of late, not quite as late as yesterday, and I finally solved the rope puzzle after only 3 streams and about a total of 2 hours spent on the problem. I finally figured out that I completely misread the puzzle description and didn't really pay a lot of attention to it, if we're being quite honest. And that was why I completely bodged my solving attempt. So, for today, we shall go to the Advent 2020 folder, go to 2022, and execute AOC N, which is the script I wrote to create a new day directory. Now that I think about it, we probably want to do this in the terminal in my editor to make things a little bit more streamlined. And we got about 30 seconds before we're starting here. Let's switch scenes. I'm fully prepared and ready. My CLI has been doing good work. I'll be going to folder 10 once it's fully downloaded, but I think I'm going to stay in the editor if I can at all help it. And we got about 10 seconds before the next day will be starting. Set up here. And let's go. Okay. Oh no. Oh no. Oh no. Hmm. Um, well, um, I think I want to start a new method called maybe end. Um, try return int s, accept return. Okay, so if int 0 equal nop at x. X1, x plus equals 1, cycles 0, cycles plus equals 1 plus equals 2, hold x, x, if cycles greater than marker, print I plus equals 1, I equals 0, marker equals. Interesting. Okay. Some. Not correct. What's going on here? What's the signal strength? Oh, you multiply it by the marker. Okay. Um, well, I screwed this one up because now I have to wait 34 seconds. Okay, I think this should be correct. Okay. Still not correct. Why? Okay, wait. Am I reusing variables 2 times or something? You know what it is? I think I gotta, like, no, that's not what it is. Okay, what's the issue? Let's read through this again. During the second cycle, x is still 1. During the third cycle, x is still 1. After the 6, okay. During the cycle. So what we want is probably greater equal? I don't know, we can try. Yes, okay. I'm a bit annoyed that I wasted some time with the waiting, but it's only 30 seconds, so what gives? What? Um, count the pixels of the CRT, 40 by 6. The CRT draws the top row of pixels left to right. And okay. Like the CPU, the CRT is tied closely to the clock. You should be able to determine what's visible. The first few pixels are drawn as follows. Begin executing, add X. During cycle 1, CRT draws pixel in position 0. If the sprite is positioned such that one of its 3 pixels is the pixel currently being drawn. What? buffer append this, else buffer append this. Print buffer up to 40. Buffer equals buffer 40 cut. There's like 5 lines or something. Oh. Does this look right? I don't think so. So it only sets the horizontal position. So it's gonna do modulo 40? Yep. But this is starting to look like something. Almost? It's like off by 1. Oh no. Uh, +1. Oh my god. There's one more row. PLPAFBCL. Yes. Okay. Did I get any points with that? I don't think so, because it's been 17 minutes, but wow, this was pretty damn involved. So how often do we do this print? Let's turn this into a loop 7, I guess. Interesting puzzle. Very confusing thing with the whole. I don't even. I still don't fully understand it, to be quite honest with you. Um, I should probably do an OCR or something. I should also probably make the characters twice as wide. Yeah, this makes it way easier to read. PLPAFBCL. Um, this is one of the days where you can't just pipe the output into the CLI because you have to read something. This happened before in previous days. Um, so okay, let's just very quickly go through what happened. Why did I write maybe int? Because I wanted to be able to get the integer out of the second parameter of the line very easily. I turned marker into an array, so it's always going through these, increasing the marker index by 1, so it's always checking the next marker. It's checking if the cycle is greater or equals, because if it is, it means we're past the cycle that we wanted to get the value for. So it's very simple. We just get the value before this cycle. I think it's a bit confusing that they're saying if add takes 2 cycles, then in the cycle number 2, it's still the old value. Previously, I had just greater, which made a lot more sense in my opinion, but it has to be greater equals. This is the one mistake we made here. And I still have no idea why I had to say this one is +1, to be quite honest with you. I guess it's because I was saying the position is 2. I think that's where the mistake comes in. I don't know why, for some reason here I was thinking 1 based, here I was thinking 0 based, but I think, yeah, this is how we fix that. Um, yeah, man, really, really happy with this. It's definitely more, commit push, add data. It's definitely more unique of a puzzle than the previous days. The previous days were more straightforward. This is pretty, it's very different. It's more visual. The whole display thing was kind of interesting. This took me a very long time to understand how the marker is supposed to work. I hope I wasn't the only one who took some time to solve this one. Let's see how the leaderboard looks. 213 and 409. That's all right. Not great, not terrible. Yeah. Let me just think if there's anything special here. I mean, of course, we're just cutting out the first 40 characters and then running through this loop again, printing up to the first 40 characters using empty string join to put everything on one line. And no other magic really going on here. This is the, well, I guess there's a little bit of magic. This is the modulo operator. This operator is pretty much divided by 40 as an integer and then remove, okay. So 7 divided by 2, we already covered this, is 3.5. 7 divided by 2 as an int is only 3. And if you do 7 divided by 2 as an int, times 2, 7 minus. Yeah. So this is what the modulo operator does. So we can define it like this. Modulo is equal, this is like computer science 101. You're going to learn this in CS. But I'm going to explain it anyway, just for once. Modulo is equal of lambda x and y, rather left-hand side and right-hand side. And we return left-hand side minus left-hand side all divided by right-hand side times right-hand side. So modulo of 7 and 2 to 1, modulo of 39 and 40 is equal to 39, and 41 of 40 is 1. And in Python, there's a shorthand operator for this, which is the percentage sign, so you're going to get the exact same results as we just got. In reality, all it means is as long as the number is bigger, so for example, this here is how many times does the number 10 fit into 100, or rather, regardless of how many times it fits, just give me what's left. So 10 fits into 110 times, and then there's the number 1 left, and it's like the remainder. So if you keep subtracting the number 10, when do you end up with something that's smaller than the number you're trying to subtract?